Welcome back everyone. Today we are going to do a really quick and really dirty synthesis of diethyl ether via the Williamson ether synthesis. For this you will need sodium metal, chloroethane and ethanol. As I said, this preparation is quick and dirty, therefore we are not going to use any stoichiometry. You can do that, but I didn't want to do it, and we are going to use this as the only reaction vessel. We start off by cutting off a big chunk of sodium metal. Sodium metal oxidizes rather quickly in air. Afterwards, we make it dry because there's paraffin oil on top of it and we don't want that. And we cut it into even smaller pieces, which are added to our reaction flask. To the reaction bottle, just barely enough ethanol is added to dissolve all of the sodium. During that step, sodium ethoxide and hydrogen gas are formed. After all the sodium had reacted, we took away the bottle and boiled away all of the excess ethanol, leaving behind only the sodium ethoxide. After boiling down the ethanol in the sand bath, we removed the last bit of ethanol using a vacuum. Afterwards, the bottle only contained nice and white sodium ethoxide. Then really large excess of chloroethane was measured out and added to the sodium ethoxide bottle. During that step, the actual Williamson ether synthesis takes place and sodium chloride and diethyl ether are formed. We close down the bottle and put it into a water bath. You have to be really careful while doing this because overpressure builds up because of the ethyl chloride and you don't want this glass thing here to shatter. The next day, the bottle was opened up slowly. Leftover chloroethane directly started boiling. The contents of the bottle were put into a syringe containing a cotton pad for filtration. Leftover sodium ethoxide and sodium chloride should be left behind. The bottle was rinsed out using some chloroethane. To speed up the filtration, we simply use the plunger of the syringe to press everything through. Afterwards, we simply waited until all of the chloroethane has evaporated. Because the boiling point of chloroethane is around 13 degrees Celsius, a thermometer was used to determine when the temperature of the solution went higher. We stopped to let it stand at around 16 degrees Celsius. Afterwards we were left with this dirty liquid. Let me pour it into a beaker and show it to you. Looks like this. We couldn't get all of the stuff out, but for this really small yield I didn't want to bother with distilling it. It definitely smells like ether, and to show you that there's no chloroethane left, we actually heated that stuff up directly below the boiling point of diethyl ether. I am going to light it and show you the difference between diethyl ether burning and chloroethane. A nearly invisible flame, you see. It actually went out. Let me light that up again. You can just barely see the flame, if at all. Let me take that into a dark place. When inside, the flame becomes actually visible. It's pale blue, the flame of diethyl ether. Now to the chloroethane. I've actually got a lighter here that is filled with chloroethane, but I am going to put some chloroethane in here and light it up. Even with the lighter, you can see chloroethane has a more yellowish flame, and it also produces a lot of black smoke, not visible on the video. By the way, when you burn chloroethane, do not inhale the vapors. The flame is definitely visible, and if you shake the beaker, you can see that it produces black smoke. If you liked today's video, make sure to drop me one of these and consider subscribing to my channel for more stuff in the future. Future videos are definitely going to be higher quality than this, but I really want to make diethyl ether with this simple route, and it seemed to work. I wish all of you a nice day. Until next time. Bye.